Let's continue further. The next up will be the topic of the mutable and immutable. As obvious as it is, the mutable means the content could be changed, or immutable means it cannot be changed. The data types that we have in Python, there are some which belongs to mutable data type, and there are some which are immutable, out of which the integer, the float, the string, and then the tuple. I repeat, the integer, the float, the string, and the tuple are immutable data type, which means they cannot be changed or the values cannot be modified. However, you have two data types, namely the list and the dictionary, which are mutable in nature. Now, when I say immutable, mutable at the outset, it appears to be pretty simple, straightforward, but it's not as straightforward as it appears to be. Let's come up with a situation. Let's say I have 4 assigned to A, right? And then I check the memory address of A. Or before that, I just try to change A to 5. And then I try to print the value of A. I get the answer as 5. So the data type of A, since this is an integer literal, this is an integer literal, the data type of A has to be the integer. But just a while back I said the integer is immutable, but as per the example, as per these two statements, it looks like the value of A could indeed be modified or it could be changed, right? So you could sense some kind of contradiction. I've said it's immutable, unchangeable, but here it looks like as if it could be changed. That's not what I meant. Now look here. Now when I say modified, modifiable, or changeable means, are you able to change the value in place? Or in other words, are you able to change the same value in the same memory location? Now this is important. With regard to mutable, immutable, you're referring to whether you can change a value in place, or it means whether you're able to change the same value in the same memory location. This is what we are referring to. Mutable or immutable. Now let's check this out. Let's say, I'll take another example. B is equal to 10. Alright? I have B is equal to 10 and I check the memory location of B. How do you check the memory location or the address? You have the function of ID. Remember? Okay, ID of, I write here, B. Now take a very close look. Now this is the address of memory location in which the integer literal of 10 has been stored. Okay, so in other words, this is the address of the integer literal of 10. And then let's say I reassign 11 to B. Okay, I reassign another value of 11 to B, and I now check ID of B. Okay, so when I press enter, what happens here is the address changes. Okay, the address changes, which means 10 is an integer literal which is residing in this address. 10 is stored in this. Alright, now when I change the value of B's address is something else. Okay, so what does this actually tell us is the 10 which is stored in this address is not changed. Rather, the B variable, B is a variable, which is nothing but a named label which refers to a certain memory location. Remember? So rather what happens is the B is made to point to some other location. B is made to point to some other location in which the 11 has been stored. Okay, so in other words, if I just make it very simple, look here, 10 has been stored in this address. Okay, 11 has been stored in this address. So when I assign 10 to B and I check the address, I get the address of 10. But when I change or when I assign 11 to B, it looks like, the B could be changed from 10 to 11, but that's not the case. B, which was pointing to 10, it has the address of this address, right? It's now made to refer to another address, another memory location in which 11 has been stored. So the question is, 10 which is stored in this memory location, was it changed? No. Okay, so this is what we refer to integer being immutable. Okay, the 10 value which is stored in this memory location, can it be changed? No. Okay, it looks like as if the B is being changed from 10 to 11. That's not the case. B earlier points to the storage location in which the 10 has been stored is now made to point to another memory location, okay, in which 11 has been stored. Okay, so that's the meaning of, if you could change the value in place, then it becomes mutable. However, in this case, 10 which has been stored in this particular address could not be changed. Rather, the B itself has been made to point to some other values, right? So this is, what we mean when we say integer is immutable in nature. Okay, immutable data type. The same value in the same memory location, can it be changed? The answer is no. I showed you through the address, right? So in the earlier example, it looks like it's mutable in nature. Oh, the value of A is 4 initially, but it could be changed to 5. The proof is, when I print the value of A, I get 5, I don't get 4. So it looks like, to our eyes, the integer data type is mutable in nature. But the fact of the matter is, the value in place cannot be changed. Rather, the variable is being made to refer to other memory location, right? So this is the reason why in Python, variable is not a storage container. In earlier programming languages, it's a storage container. It will have a fixed address. Okay, so let's say it's A, and then it will have a certain address. You assign 4, 4 will get into it. You assign 5, 5 will get into it. The memory address will always remain the same. So in earlier programming languages, the variables are like storage containers. The memory address will always remain the same. The values could be changed in place. However, that's not the case in Python programming language. In Python, the variables are the named label which are used to refer to the memory location. The moment you change the value, it will redirect, right? So since the value in place or the same values in the same memory location cannot be changed, we call it as immutable. So same is the case with the string, and then you have the tuple, right? So I don't need to show examples, with regard to the rest. So this is the meaning with regard to the mutable or immutable, right? Now, when I say list is mutable, okay, let's check list. Let's say I have a list by the name of li is equal to 1, 2, and 3, all right? And then I check the address id of li, all right? Take a closer look at this address. Now let's say I would like to change the content of the list. I would like to change 1 to 10. Okay, I'm making some kind of modification, right? So I have li of just like the string. We could access the individual elements through its index. The index always starts from 0, 1, and 2. Now in order to, okay, no problem. Now let's say when I have li of 0, okay, li of 0 means, this entire list is represented by the list variable of li. When I say li of 0, I'm referring to the 1. Li of 1 means 2. Li of 2 means 3. So let's say I would like to change 1 to 10. Okay, I press enter, I check the list, it's been changed from 1 to 3 to 10 to 1. Now let's check the address of LI. Okay, now when I check the ID of LI 63888888160160. Now what happens here is I could in fact change the value in place. Same value in the same memory location could be changed from 1 to 10. When I do so, do you see the change in address? Do you see a case where the list value of LI is made to point to some other memory location? No, the memory location is exactly the same, right? So which means unlike in the integer, in this what happens is you could in fact change the value in place, or you could change the very value in the same memory location from 1 to 10. When I make the change, the address remains the same. So this is what you mean by mutable. Okay, so if you try this with dictionary, you'll be able to make changes in place. Okay, however, the data types like the integer, float, the string, the tuple, you cannot do it. All right, so perhaps we'll just try with the string in order to feel a little more comfortable. Like I said, string is a immutable data type, right? Let's just check. Let's say n1 is equal to abc. All right. Okay, I press enter, and then I check the address of n1. I get this address, and then let's make a change. n1 is equal to def. Press enter, and I again check the address of n1. The address, should be different, right? So when the value of n1 was ABC, you have this address. The moment I change it, the address changes, which means the ABC in this address cannot be changed in the place. Rather, the n1 is being made to redirect to another address, right? So this is the definition of mutable and immutable, right? So just write the point here: mutable and immutable, right? I hope I got the spelling right. Now the next topic, is the operators. Okay, operators. You have operators like arithmetic. Okay, I'm not sure about the spelling. And then you have the relational, and then the logical, and then the identity. Okay, identity operators. Okay, so these are the common operators which are a part of programming language, right? In arithmetic, operators, we have the plus, minus, the unary, you have the binary, and then the modulus operator, which I've explained already. And then there is one more operator called exponent operator. So if you use 2 asterisks, then the base will be raised to the exponent. 2 raised to 3. If you want to express this, then you'll have to use the 2 asterisks. So the 2 asterisks means the exponentiation operator. You will get the answer as 8. 2 raised to 3 is 8. So 1 asterisk means multiplication, and 2 asterisks means the exponentiation operator. And then you have the modulus also, right? 5 modulus 4. You will get the answer as 1. We are referring to the remainder. So this is the percent symbol, which will return the remainder on dividend by a divisor. All right. And then I would like to bring this into the picture. How Python handles the division involving negative numbers. Okay, it's a little different from the usual division process which we find in mathematics. It's a little different. Let's try to figure out. Let's say when I divide say 7 by 3. Okay, so 3 times 2 is 6, and then you get the remainder of 1. This is the normal math. The remainder should always fall in the range of 0 to 2. The divisor is 3, which means the remainder should always be between 0 to 2. It cannot be 3. If it's 3, again, it's divisible, right? You know this. So one important thing to be noted is the remainder should always fall in between the 0 and a number less than the divisor. If it's equal to the divisor, again, the division process could go on, right? So if the divisor is 2, the remainder should be 0 and 1. If the divisor is 3, the remainder should be either 0, 1, 2. So this will go on and on. However, now let's say if we try to divide something like this. Let's say you have -3 and then you have 7. The divisor is negative and the dividend is positive. So the normal tendency is to just multiply the -2 with -3, and the answer will be how much? It will be +6, and then you will get the remainder of 1. Okay, so we'll try this and check out whether the answer equates to the normal mathematical process, right? So according to this, we should get the quotient as -2 and the remainder as 1. Okay, so we'll see whether we're getting the right answer or not. So 7, and then remember we need to use the floor division operator, not the float division operator, because we're not dealing with the fractional values, right? 7 divided by -3. Okay, so how Python handles division process involving negative numbers. So that's the topic. So when you press enter, you get the answer as -3. However, I get the answer here as -2. So there's a difference here. And then let's check the remainder. 7 modulus -3. I should get this, okay? But again, I get a different answer, right? So which means the Python surely handles the division process a little differently. How it does, let's try to understand. So again, let's have 7 here, and then let's have -3, all right? The problem with this is, look at the remainder. Look at the remainder. The remainder should be between 0 to -2. This was the rule. This has to be the rule. The remainder should always fall in between 0 to a number less than -3. Okay, but this is, you see a little contradiction here, right? So in order to make sure that the remainder falls in between this range, we'll have to make a little adjustment. So now when I wrote -2, that's out of question, right? So why not have -3? So -3 into -3 is +9, right? You have +9, and then 9 needs to be subtracted from 7. You will get the answer as -2, right? So now look at this. Now when you make this little adjustment, look at the quotient. It's -3. So 7 divided by -3 is -3. Look at the remainder. This remainder falls in between the range of 0 to -2, right? So as you could see here, it's -2 is the remainder and -3 is the quotient. So this is how the Python handles the division process involving negative numbers. Now let's say we'll try another combination. Just get rid of this. Okay, let's say we have -7 and then we have +3. Alright, so again, we'll just first work it out. So understandably, it has to be 3 into -3 is -9, right? So I'll have minus sign here. Okay, so minus into minus will change to +9, Negative 7 plus positive 9 is 2, right? This is simple math, okay? You're expected to know this. Now let's check whether we get the correct answer or not. So minus 7, and then you have the division operator. Positive 3, I should get the answer as negative 3, alright? And then let's check the remainder. Negative 7, you have the modulus operator, and then positive 3, I should get the answer as positive 2, right? So you need this little bit of practice in order to be familiar with how Python carries out the division process using the negative numbers, okay? Now let's move on to the next kind of operator. So with this we are done with all the possible arithmetic operators. Okay, you have the unary, you have the binary. Now next comes is the relational operator. Relational operator are those operators which are used to establish some kind of relationship between the operands. Okay, if it's equal, if it's not equal, if it's greater, if it's not greater. Okay, so you have these symbols, you know, which are part of the relational operators. Okay, so for example, you know, say 4 is greater than 3, you know, you will get the answer as true. So the result of relational operators could either be true or it will be false. Okay, there is no other way out. Whenever you talk about relationship, is it greater, is it less? You cannot ever say like, I don't know, you know, this could be, it could be this, it could be that. No, either it has to be true or it has to be false. So you have relational operators like, you know, the 4 greater or equal to 3, you know, you will get the answer as true. Is it greater or is it equal to 3? You know, it's true, right? Now likewise, you have another operator like, not equal to 4 exclamation mark, and then you have 3. So exclamation mark equals sign, then it means the not equal to operator, right? So when you press enter, you will get the answer as true. 4 is not equal to 3, the answer is true. So these are, you know, the relational operators. Now the next up is how relational operator works with the string. Now this is again very important. Now let's say if I write something like this, A greater than A, alright? When I press enter, I get the answer as true, right? And then when I say B greater than C, okay, and then when I press enter, I get the answer as false. So the string or the characters are able to be compared with each other, which means, you know, there should be some kind of a system, you know, via which these characters could actually be compared against each other numerically, right? Now when I say A is greater than B, B is greater than C, you know, for sure there is an element of numbers behind these characters, right? So the characters or the strings are compared based on their ASCII values, okay? Even though the characters which are used in string, like I said in the beginning of the video, are Unicode characters, but in order to make the explanation a little simpler, we'll bring the ASCII code into the picture so that you know, you will feel a lot easier to understand the concept, right? So you have this ASCII codes for all the characters. ASCII code has 1 byte. I want everybody to know this. ASCII code has 1 byte. 1 byte means how many bits? ASCII, okay? This is again a character encoding system. What is ASCII? ASCII means American Standard Code for Information Interchange. American has just English language, right? So this is a system through which all the English language based characters are assigned a certain code or a certain number. Why are they being assigned a number? Like I said, the machine ultimately has to convert the numbers into the combination of zeros and ones. Okay, so which means Each and every characters of English language are assigned a unique code called ASCII code. Okay, so it's a good idea if you could learn this by heart. Small a ASCII code is 97, right? And then small z will have ASCII code of 122. Big A has ASCII code of 65, and then big Z has ASCII code of 90. All right. So if you count the numbers from 65 to 90, it will be 26. Don't just subtract. If you subtract, you will get just 25, right? But you need to include this number, so that will make 26. So 26 alphabets, 26 lowercase, 26 uppercase. So like I said, the ASCII code has storage capacity of 1 byte. 1 byte has how many bits? 8 bits. 8 bits could represent how many possible combinations? Remember the formula 2 raised to n. Okay, so 2 raised to n, the value of n being 8, will give us 256 possible combinations. So these 256 number of combinations are more than enough to represent all the English language based characters. Okay, so you already have 26 here, 26 here, right? So that makes like 52, and then count all the punctuations, all the digits, all the special characters. If you put together all the possible characters of English language, the numbers will stay comfortably within the limit of 256, right? So ASCII uses 1 byte. 1 byte has 8 bits. 8 bits could come out with how many combinations? 256 combinations. 256 combinations, will easily be able to represent all the English language based characters, right? So if you want to check the ASCII code of a certain character, you can use a function called ORD. ORD means ordinal. Ordinal. Okay, this is another name for the code or the ASCII code. All right, ORD. And if I write small a here, and then upon pressing enter, I should get the answer as 97. So ORD is a function which will return the ASCII code of an enclosed character, right? So if I do something like this, okay, check out small z, I'll get 122, and then ORD, big A will have 65, and then ORD, big Z will have 90, all right? And then ORD, remember the space. Space is also a character. It is as important as the characters like A, B, C. Okay, you cannot ever say like, oh, this space is not visible, it's invisible to our eyes. But technically, space is indeed a character. So I guess it has to be 32, right? So likewise, if you try out all the characters up on the keyboard, each one of them will have a unique code, and that is nothing but the ASCII code. So when the characters are being compared against each other, their ASCII code or ordinal values are compared against each other, right? So when I say small a is greater than big A, right? Big A, the ASCII code of small a is 97, the ASCII code of big A is 65. So 97 is greater than 65, it's very much true. So you get the answer as true. So likewise, when you compare something like this, ABC greater than ABC. So will the answer be true or false? The individual characters will be compared against each other one by one. So just like how the dictionaries are written. Okay, so that's that is something we actually call it as lexicographically. Lexicographically means the way the dictionaries are written. Okay, let's say if I have a letter like AA, all right, and then once I am done with AA, then it starts with AB, okay, and then once I'm done with AB, then I'll have AC. Okay, so the way the dictionaries are written, we actually call it as lexicographically. So that's the order in which the words in the dictionaries are written. In the similar manner, the comparison in the Python takes place. Not just in Python, the rest of programming language. Now ABC, if you just check out this, small a and small a is equal. Okay, they are equal, and then the next character will be compared. Small b will be compared with big B. Small b will have 98. Okay, big B will have 66. So the answer has to be true. Okay, so this is how the characters are compared against each other, right? So this is with regard to the relational operators, like greater than, less than, equal to, not equal to. The fact of the matter is the relational operators could indeed be applied to the string values as well, right? And then we'll now move on to identity first, right? So this is a little lengthy. I don't think I'll be able to finish today. So I'll just finish this. Identity operators. There are two identity operators. The first one is S. Or you can actually call it as membership operator, or you have this S not. Okay, so again, this two are the operators which are used to check the membership, whether this particular value is equal to another value or not. Okay, so we'll just try to check. Now the thing about S operator is, S operator will always check the memory location. Okay, S operator will always check and do the comparison based on memory location, right? Now let's say if I have something like this, A is equal to 10, right? And then I have here B is equal to 10. And then when I write A is B, I get the answer as true. Okay, the reason is A is a label which will point to the address which has integer literal of 10. B will again be a label which will point to the same address. The reason is in that same address you have the value as 10. Okay, so when I assign 10 to A, what happens is A is being made to point to an address in which you have the 10. When I assign 10 to B, what's happening is again you have another variable called B, and B will again point to the same address. In that same address, you have the value of 10. So when I say A is B, then what happens here is, you will get the answer as true. Okay, so it compares the memory location, right? But if you write again A is equal to B, you will again get the answer as true. Now unlike S operator, this equality operator compares the value. It compares the value, alright? S compares the memory location. Okay, so in order to differentiate between the two, now let's say I have something like this. A equals ABC. Okay, so you have a string value of ABC in A. And then using the input function, okay, using the input function, I would like to receive a value. Say enter a string value, right? Okay, I hope you're familiar with this. Now when I press enter, I'm being asked to enter a string value to B. I enter ABC, right? So when I enter ABC, what happens is B will also have the value of ABC, right? So if I print B, I get the answer as ABC. So the value of A is ABC. The value of B is also ABC, but when I check A is B, I get the answer as false. So what happens here is, whenever you use input function to receive input from the console means the input means the devices through which you enter the input, you receive the input as a programmer, right? So whenever you use input function to receive the input from the terminal, a new object is created. This is an object, okay? This is a storage location, and then the moment you use this, it creates a new object, means the new object will always reside in a new memory location. Understood? So which means if there is a new memory, if it's a new object, it has to be a new memory location. If it's a new memory location, it should have a new address. Okay, so this is the reason why when I say A is B, I get the answer as false, because the addresses are different. So if you just check the address of A and B, let's see whether they are same or not. They are not equal. Understood? So initially when I assign ABC directly to A, it has a new memory, it's a new object, it will have a new address. But when I receive again ABC, but through a function of input, when you try to receive a new value from the console or the terminal, even though the values are similar, it will create a new object. New object means new addresses. So this is the reason, even though despite having similar values for A and B, the S evaluates to false. So the crux of the matter is S operator does the comparison based on the memory location, not on the values. You need to know this. However, if I do this, say if I just if I print the value of A, it's ABC, print the value of B, again it's ABC, but when I say A is equal to B, you get the answer as true. So clearly, it tells us that this equality operator compares the values of the variables. Okay. However, the S operator compares, the memory location. Again, this is one important thing, right? So just like you have S naught, it's just the opposite of this. Okay. Let's say you have A, S, not B. Just guess. You will get the answer as true. Remember, S or S naught does the comparison between the memory location, right? So the address of A is not the same as the address of B. Okay, so you get the answer as true. And then, however, if I write A is not equal to B, then you will get the answer as false. Right? It's not that difficult. Just a matter of time before you will get used to. For sure, right? And so these two are the identity operators. Okay, so I think it's better to stop here. It's almost 1 hour. So with this, I would like to wind up my today's lesson. I'm sure you must have understood the concept. And one important thing to be noted is you need to watch the videos again and again. Okay. Only then you'll be able to understand the concept much better. So with this, I would like to wind up here. Thank you, and please take care.